Email has been around for decades, but it's still an essential tool for business, sharing ideas, and moving sensitive information. While email providers have stepped up their security game over time, it's often not enough to keep your data fully protected. That's why more developers and organizations are turning to custom email encryption solutions tailored to their unique security and compliance needs. But creating a custom encryption solution isn't as simple as writing a few lines of code. It's about building something that's reliable, flexible, and secure from the ground up. This involves careful decisions on frameworks, encryption protocols, and rigorous testing. If you're considering building your own solution, this video will walk you through everything you need to get started and what you should prioritize. Why build a custom email encryption system? Plug-and-play encryption tools don't always fit the bill. If you're handling legal documents, financial records, medical reports, or government contracts, trusting a third-party provider may not sit well with your risk profile. Off-the-shelf encryption doesn't always offer control over how keys are generated, where messages are stored, or who gets access under what conditions. Custom email encryption systems allow you to tailor security policies to your unique environment. That might mean integrating directly with your app's login system, enforcing company-wide end-to-end encryption, or creating a seamless user experience that doesn't require tech savviness from employees or clients. Even more importantly, custom solutions let you align with regulatory standards without unnecessary bloat. You control everything from how long a message is stored to what kind of metadata is encrypted. Choosing the right development frameworks. One of the first decisions you'll make is picking the right development stack. Your choice will depend heavily on where and how your encrypted email system will be used. For backend infrastructure, frameworks like Node.js with Express, Django, Python, or Spring Boot, Java are popular because they offer mature libraries, scalability, and excellent third-party support. If you're building a web-based interface for secure messaging, React, Vue, or Angular can give you responsive UIs and tight integration with encryption APIs. If your use case leans toward mobile, React Native, Flutter, or native Android, iOS development may be a better fit. Mobile brings its own set of challenges for encryption like secure storage of private keys on device, but it also gives you the opportunity to enforce client-side security. Libraries like OpenSSL, libsodium, or GNU Privacy Guard for PGP-based encryption are invaluable at this stage. They save you from reinventing complex cryptographic functions. You should never attempt to write your own encryption algorithms. As cryptographer Matthew Green once said, don't roll your own crypto. Ever. Key security considerations when developing. If encryption is the lock, then keys are, naturally, the keys. And just like physical keys, managing them securely is absolutely critical. This is arguably the most challenging aspect of building a custom email encryption system. You need a robust key management system (KMS) that can generate key pairs. For asymmetric encryption, each user needs a public and a private key. The public key can be shared freely while the private key must remain secret. Securely store private keys. This cannot be emphasized enough. If a private key is compromised, all messages encrypted with its corresponding public key are vulnerable. Solutions can range from hardware security modules (HSMs) for high-assurance environments to secure enclaves within modern processors or robust, encrypted file systems with strict access controls. Distribute public keys reliably. How do users get each other's public keys? A public key server, similar to how PGP operates, is one option. Direct out-of-band exchange is another, though less scalable. The mechanism needs to be trustworthy. Manage key lifecycle. Keys aren't immortal. You need procedures for key revocation if a key is compromised, key expiration, and crucially, key backup and recovery. Imagine losing your private key and suddenly being unable to decrypt years of sensitive emails, a nightmare scenario that proper key management prevents. The user experience, integration, and interaction. Even the most cryptographically sound system is useless if no one can or will use it. This brings us to the user interface (UI) and user experience (UX). A primary reason for the limited widespread adoption of some existing E2E solutions is their perceived complexity. Your custom email encryption solution needs to be as seamless as possible. Consider your integration strategy. Will you build a plugin or add-on for popular email clients like Outlook, Gmail, or Thunderbird? This offers familiarity for users but can be complex due to varying client APIs and versioning. Alternatively, you might develop a dedicated, custom email client with encryption capabilities baked right in. This provides maximum control over the user experience but is a significantly larger development effort. Another viable option is a gateway or proxy server that handles encryption and decryption before emails reach the standard mail server or client, offering centralized control for organizations. Whatever your approach, prioritize clarity in the UI. Exchanging public keys should be intuitive, not a labyrinthine process. Error messages should be informative and actionable, guiding the user rather than frustrating them. Remember, people will gravitate towards convenience. If security is too difficult, they will find ways around it, compromising the very purpose of your solution. Security considerations and testing procedures. This is where the rubber meets the road. Developing a secure system is an ongoing battle, not a one-time event. Threat modeling. Before a single line of testing code is written, conduct thorough threat modeling. Identify potential adversaries, their motivations, and likely attack vectors. This helps you design countermeasures proactively rather than reactively. Secure coding practices. This goes without saying. Follow best practices to prevent common vulnerabilities like SQL injection, cross-site scripting, buffer overflows, and insecure direct object references. Static analysis tools can help identify potential issues early. Now, if you're ready to strengthen your cybersecurity skills and protect yourself online, I have a free resource for you. Download our free security checklist at TLRiz.com. It's packed with simple, actionable steps to help you stay safe and build your knowledge. Want more personalized help? You can request a free consultation with our cybersecurity experts. Or if you're curious how TLRiz works in real time, request for a demo to see how TLRiz AI agents work. Now let's get back to the business of the day. Comprehensive testing. Secure system development begins with unit testing to ensure each component, like encryption or key generation, works as expected. Integration testing checks how well modules interact, especially key management and encryption engines. Security testing follows, including penetration testing by external experts and automated vulnerability scans. Critical code audits by experienced cryptographers help catch logic flaws that tools might miss. Finally, usability testing ensures the system is user-friendly because even the most secure system fails if it's too hard to use. Real security blends technical strength with practical, accessible design. Regular updates and patching. The world of cryptography is constantly evolving. New vulnerabilities are discovered and algorithms are sometimes deprecated. Your solution must have a robust mechanism for applying security patches and updates to both your custom code and the underlying cryptographic libraries. Staying current is non-negotiable. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss an update.